we dealt with volume of cylinders and pyramids. I'm sorry, volume of prisms and cylinders. So there are relationships between a cone and a cylinder, and between a pyramid and a prism. So here's what I have. If you guys will focus on the left first, what we have is a cylinder and a cone inside of it. And I used to have a great set of plasticware, and I literally had a plastic cylinder and a plastic cone that fit right inside of it. So the base of the cone is the same size as the base of the cylinder. They're exactly the same size. This is off a little bit, and they should fit perfectly. They don't. But the bases are exactly the same size. Not only that, the height of the cone is exactly the same size as the height of the cylinder. They are the same size. Height of the cone is the same size as the height of the cylinder. Now, you guys have on your notes, you got a box with the formula, right? Okay, I gotta find, I am like not even close here, so I'm gonna pause for a second. Okay, I'm back. So anyhow, if you look up here, I know why, because I didn't give you these pages. I just want to get you to think first. Okay, so here's the point right now. The height of the cylinder and the height of the cone are exactly the same. The base of the cylinder and the base of the cone are exactly the same. So the area of the base of the cone is exactly the same as the area of the base of the cylinder. They're the same size. And the height of the cone is exactly the height of the cylinder. So if I were doing the cylinder, you don't need to write this, volume of a cylinder would be, use a little color here, area of the base times the height. Thank you. So the volume of the cylinder, again, you're not writing this. You don't have this page. I'm just getting you to think. Would be area of the base times the height. Now again, if I were to do the volume of the cone, it has area of the base and it has height. And guess what? These are exactly the same. This area of the base is exactly the same as that area of the base. This height is exactly the same as that height. Therefore, the relationship of the volume has to do with a ratio. And I used to love having the plastic ones because I would fill up the cone with water and say, if I start filling up the cylinder, how many cones worth of water can I fill it up with? Or if I take the cone and pour it into the cylinder, how full would the cylinder be? So that's the concept. If I took that cone, remember they have the same area of the base, they have the same height, and I filled it up and poured it into the cylinder, how much volume would it take up? Would it take up a fourth? Would it take up a half? Would it take up 3/4? How much would it take up? Anybody have any idea what the amount is? How much would it take up? What do you think? So again, look, do you understand? We've got all this space between the cone and the cylinder, right? The cylinder has does it have more than twice as much than the cylinder? If so, then how does that relate? So what we're trying to get at is, what's the relationship? And here's the thing, before I go too far, we also have an exact same prism and pyramid. So what is the volume of a prism? And it is area of the base times the height. Base in this case is a rectangle. What is the volume of the pyramid? Well, again, it's going to be area of the base, exact same area. They're the same area and the same height. They have the same height. And the relationship here is exactly the same as the relationship there. So will the cone fill up the cylinder, or will the pyramid fill up the prism? Halfway? More than halfway? Less than halfway. Let's start there. 3 choices. Will the cone or pyramid fill it up halfway, less than half, or more than half? All right, those are your 3 choices. Let's go less than half, halfway, more than half. Pick one. All right, I want everybody to pick one. I'm going to ask you your vote here in a moment. If I were to fill up that cone with water, that would be its volume, and pour its volume into the cylinder, how much of the cylinder would it fill up? Less than half, half, more than half. All right, those are your 3 choices. Just pick one. All right, here we go on 3. 1, 2, 3. Okay, I heard half, less than half. Anybody go for more than half? Okay, it is not more than half. And it is not half. It is indeed less than half. Okay. So if I had them here, and I wish I had a set from other school, I had them, and I don't have them here at this school. But I would show you clearly how it's not half. It's less than half. So again, the whole key is what we're after is how much then? It's not a half. So anybody have any idea what our multiplier is going to be? So if it would have been a half, we would multiply by a half. Volume of a cone, if it would have been half, would be half area of the base times height, but that's not it. And volume of a pyramid would be half area of the base times height, but that's not it. It's less than half. So I need a fraction less than half. Anybody got an idea? What is our fraction? Luke? 1/4. Nice round number. Anybody like 1/4? It is not 1/4. Actually, it is more than 1/4. So it's more than 1/4. It is less than a half. Nia. It is indeed 1/3. And again, if I had the plastic where I'd prove it to you by pouring the water from the cylinder, from the cone into the cylinder, and from the pyramid into the prism, and you'd see it would fill up 1/3 of it. Those that wouldn't believe me, I usually take it and fill it up 3 times and show you how then it completely fills it. It takes 3 cones to fill up the cylinder. It takes 3 pyramids to fill up the prism. So the relationship is 1/3 area of the base times the height. Now you need to remember that. You can't forget it. So don't forget, you got a 1/3 area of the base times the height. So it's just like doing the volume of a cylinder and just like doing the volume of a prism, except you got to do 1/3. And look, it makes sense. It comes to a point. Don't do this in your notes, but the associated prism would be, up to here in 3-dimensional. I'm in trouble already. I probably need a angle line or whatever, that associate. No, that's ugly. Who knows? Does that look? No, it's ugliness. Need you artistic people. No, come back, wherever you were. All right, there it is. So anyhow, don't forget the 1/3. Now, I spent a lot of time trying to get you to think of 1/3. You got to remember it, because if you don't remember the 1/3, you're going to get these wrong. But look, here's the point. When it comes to a point, then the volume is 1/3 area of the base times the height. 1/3 area of the base times height. So don't forget it. Let's put it in practice. Find the volume of the pyramid. So we'll start like we always do with the formula. I usually go PYR for pyramid. And again, I'm putting a subscript to help my brain to keep track that I'm dealing with a pyramid. Volume of a pyramid, 1/3. Let's stay with color. Let's go in red. Area of the base. And then let's go in green times H. Now, before we go any further, I don't want you to go ahead. I just want to show you something. Every once in a blue moon, you'll run against this formula looking like this. Now that's not 1/2 base like the base of a parallelogram or base like the base of a triangle. That represents 1/2. This is supposed to be area of the base. And they use a capital B. All the other times we were doing like the base of a trapezoid, the base of a triangle, the base of a parallelogram, the base of a rectangle. Didn't we always use lowercase b? We did, and we did it on purpose. Now again, I don't care for that notation. I don't think that's the best way to do it. I think area of the base is better. But be aware, you might see it that way, and I want you to be aware that's what they're talking about. Okay? Got it? You see a capital B, they mean the area of the base. Remember the last problem we did on Friday? When they gave you the area of the base, and you're like, didn't really know what to do. Well, they were trying to help you out. Same kind of concept there, area of the base. Okay, let's work the volume of our pyramid. So a third is a third. Somebody tell me what to put in for area of the base. Everybody should be thinking, what do you want to do for area of the base? Brendan?
80 inches.
Okay, so not correct. 80 inches is not correct. Tell me the values to put in for the area of the base. Kristen?
10 times 10.
No, that is not correct either. Numbers to put in, here, I'll help you out. This is the base right here. Right, that part of the pyramid. The part it's sitting on is the base. So, Luke, give me the, what do I put in to figure out the area of the base? We're getting closer. Chloe? Nope, there's no 1/2. The base is not a triangle. Edward?
Base, length times width.
So tell me what to put in. What numbers for length times width?
10 inches times 8 inches.
Correct. 10 inches times 8 inches. I don't know how many times I've mentioned to you guys to keep your units involved. Brendan would have been correct if he would have said inches squared, but he said inches. And that's not going to cut it. And somebody over here said 8 times 10, but they didn't give the units again, and you got to include your units if you're smart. If you're not smart, don't include your units. But you'll get problems wrong. All right, in this one, they only give you one other value. Let me try to be clear for you guys. By this 6 inches, they mean this value right here, which is the height of the pyramid. Height, as always, perpendicular from the base to the opposite vertex. And so the height of the whole thing is 6 inches. Are we going to end up in cubic units? Yes, because we have inch times inch times inch. All right, the rest is just your calculator. So grab your calculator, see if you can punch it in correctly. 1/3, 10 times 8. Somebody raise your hand for me when you got that. Christina, what do you got? 160 inches cubed is correct. Area of the base times the height. Now, guys, honestly, your pyramid could have a triangular base. It could be a triangular pyramid. This is a rectangular pyramid. You name the base rectangle, and we say a rectangular pyramid. You can have a triangle as a base, so you can have a triangular prism. You could have a pentagon as a base. You'd have a pentagonal prism. You can have an octagon as a base, an octagonal prism. Now, we haven't dealt with the formula for area of polygons. It's 1/2 AP, and the A is the apothem, but you don't know what that means, so we won't worry about it. But there are different kinds of pyramids. This is a rectangular pyramid. You could have a trapezoidal pyramid, where the base is a trapezoid. Possible. All right? All those are possible. It's still 1/3 area of the base times the height. All right, let's do the cone. So volume of the cone. So again, you're always going to start with your formula. Comes to a point, so don't forget the 1/3. Again, I'm going to use my color. Area of the base times the height. Right? All right, so why don't you guys do this one? Finish it off. I'll do it up here. If you're stuck, you can look, but see if you can do it yourself. Make sure you're showing the numbers. Show me what numbers you're using for the area of the base. Show me the number you're using for the height, and then use your calculator. Make sure you know how to punch this in your calculator. I like to leave the 1/3 for last. Usually I'll punch this in h squared times 3.14 times 15, and then I would do what? Divide by 3. That's the way I punch it in. But again, you got to know how to punch it in to get the correct answer. So what do we got here? 64 times 3.14 times 15 divided by 3, and I've got 1004.8. Anybody agree? Okay, so you should have gotten 1004.8, and what are my units? Meters cubed. 1004.8. Make sure you know how to punch this into your calculator. It's a shame to have the formula, to put the correct numbers in the formula, and then not know what to do from there. Emily. Why? When you could. Why round it? That was that. I mean, we already, so you know, we're already rounding off pi. Pi's already a round off. Well, what do you want to go to the nearest unit? That's because the book does what the book wants to do, right? Again, what's our normal MO? To leave it to one decimal place, right? When we round, that's our normal MO. So I'm going to our normal MO. Hey, folks, everybody look up at this cylinder, at this cone. What if instead of giving you 8 meters, they told you something like 27 meters out here, which would be the what? Circumference. What would you need to use the formula? The radius. How do you get the radius if you know the circumference? Chloe? So what is the circumference formula? C equals 2 pi r. Put in the 27 meters for the circumference, move the 2 in the pi, and figure out r. Now you have the value of the radius that you can square, right? So, what if they give you the diameter instead of the radius? Just cut it in half, right? To get the radius, if they give you the diameter, chop it in half, and you're good to go. That's the idea. Now, we could make a pyramid problem a little trickier by giving you the side. So I want you to look at this pyramid. Don't do this in your notes. But what if they told you this was 10? And what if they said this side was 8? And they didn't tell you the height? Look at this. You know 10, 8, and you don't know the height. Now this is a little tricky. I'm going to give you one other value here. What if you knew, actually, I'm kind of a little off in my thing, but you know, I'm just going to leave it. This isn't really 5, but let's suppose they gave that. Do you see this little right triangle right there? Sometimes if they don't give you the height of the pyramid, you can find it using the Pythagorean Theorem. So you see this right here, this right triangle? And the height, remember, this value would be the hypotenuse, right? Going up the side of the pyramid. This would be either A or B, and you would solve for the other one. So we've already solved the Pythagorean Theorem, and you can come up with the height by doing that. Sometimes instead of putting the 8 there, they do this. That's probably the way I should have started. It would be more clear. Sometimes they'll give you the 8 here. Now this is definitely half of the 10 or 5. And again, you got the hypotenuse, you got one side, you could find the other side of the right triangle. You see that right triangle right there? So again, that's part of it, and that's how you're able to do a little bit more complex problem. Who's got a birthday? Come on in. Who's it go to? All right, who do they go to? Are they for me? Oh, man. Awesome. Thank you. How old are you? 87? 11. Thank you. Abigail, how old are you? 11. Happy birthday, girls. Thank you. I thought I was going to get one of each. That's why I took one of her.
Yeah.
So I thought, all right, I'll take one of each if they want me to. Actually, that's pretty good. Ooh, that's awesome icing. Okay. So remember the relationship between a cone and a cylinder and a pyramid and a prism. It's 1/3 area of the base times the height. Now we have a sphere. And remember, we're talking about not surface area, volume. Volume. So let me go back a second and refresh your memory. Here was, here was the surface area of a sphere. It was something pi r squared. Anybody remember the number that was the multiplier, Nia? It was 4. It was 4 pi r squared. So guess what? The top of that fraction is a 4. And math is beautifully orderly. So guess what number goes on the bottom, if you had to guess? Come on, think about what are we doing right now? We just dealt with volume of a cone and volume of a pyramid. And math is so nice. So what do you think the number on the bottom is? It is a 3. It is a 3. 4/3 pi. What's the exponent on the r? 4/3 pi r. Volume has what units? What's the only thing that gives us units in this formula? The r, so the r must be cubed. It is pi r cubed. So the volume of a sphere is 4/3 pi r cubed. So if you know the radius, it's a pretty easy problem. Let's do volume of our sphere. 4/3 pi, you know, is 3.14. And in this one, all we know is 4, so I'm going to put 4u, right? 4 units, and they are cubed. I want everybody to write that and then pause and look at me, and I want to tell you what I think is the best way to punch this in your calculator. I like to do the cube part first. You don't have to, but it's safer in your calculator. So I do 4 cubed. Watch now. Don't do it yet. Watch. You're not watching. This is the order I take it in. I do the 4 cubed times 3.14 times 4, and then I divide by 3. All right, see if you can get the correct number. Go ahead and punch it in and make sure that you're able to come up with the correct answer. All right, and hopefully you agree 267.9 units cubed. Almost 268.0, but it was 0.9466, right? So round in the one decimal place, 267. How many were able to get that on your calculator? All right. So again, you got to know how to punch that in. So if you haven't gotten it yet, keep playing with your calculator till you get it figured out, because you got to know how to do that. Got to be able to punch it into your calculator. All right, our last problem here is volume of a sphere again. Let's write our formula one more time. Volume of a sphere, 4/3 pi r cubed. 4/3 pi r cubed. What is the 12.56 meters? What is it? What does it correspond to? Colby?
Radius.
Not the radius. Not the radius. Omar? It is the circumference. If you guys see, but that's why it's along this, what's called a great circle. A great circle is a circle that has the center of the sphere as the center point. A great circle is any circle that has the center of the sphere as the center point of the circle. There are an infinite number of great circles that go around a sphere, but not every circle is a great circle. Don't write this. What if I went like this? That definitely is not a great circle because its center is way over here. Follow? But there are a bunch of great circles that exist. And again, a great circle is the circumference of the sphere. Right? If I went up here and went around, would that be the value of the circumference? Obviously not. I'm slicing the top of the ball off. So, but when it goes to the center, so that's why they put the 12.56 there. Well, look, the only thing you need to know to find the volume of a sphere is the radius. So I want you to complete this problem. Find the radius, put the value in for the radius, and find the volume of the sphere. All right, is your volume greater than 50 meters cubed or less than 50 meters cubed?
Less than 50.
It is less. 40, 30, 30, 35. All right, that is the ballpark you should be in. So let me show you guys. 33.5 meters cubed. Do you have your units? Are they meters? Are they cubed? I gave you a nice one that gave you a nice round number. Look, even if you get something like 3.2 here, just use your calculator and cube 3.2. It'll cube it for you. We generally round off to one decimal place. If the book wants it some other way, follow the book's directions. Got it? So volumes of things that come to a point, 1/3 area of the base times the height. Volume of a sphere, 4/3 pi r cubed. All right, that's the last lesson. You got your homework there. We're going to review tomorrow. We're testing on Wednesday. I'm not quizzing tomorrow. I'm reviewing tomorrow. Test on Wednesday.